Good day everyone, I am Roberto III A. Madelo and I will be discussing highway soil and bituminous materials. So, what is the introduction for highway soil and bituminous materials? Highway pavement refers to the surface layer of roadway designed to provide a smooth, durable, and safe surface for vehicle travel. Pavements are designed to withstand various loads, weather conditions, and traffic volumes. There are two main types of highway pavements called the flexible pavement and the rigid pavement. For the flexible pavement, it is made up of layers with the top layer of being an asphalt, while the rigid pavement, it is constructed with concrete or the Portland cement concrete. It relies on the slab's rigidity, and strength to distribute loads. And now, let's discuss bituminous materials. So what are bituminous materials? Bituminous materials refers to any material that contains bitumen, a black, sticky, and viscous substance derived from petroleum. These materials are widely used in construction, especially in road pavements, because of their excellent binding and waterproofing properties. So these are types of bituminous materials. The most famous is the asphalt, which is a mixture of bitumen and mineral aggregates. Another example is a bitumen, which is a pure binder obtained from crude oil destruction. Cutback bitumen, which is a bitumen diluted with volatile solvents like kerosene. Another example is the bitumen emulsion, which is a bitumen dispersed in water with an emulsifier. And lastly, tar, a bituminous product from coal or wood distillation. So let's talk about asphalt. So asphalt is an example of a bituminous material. So asphalt, like what I said earlier, is a black, sticky, and highly viscous or semi-solid material that occurs naturally or is derived from the refining of crude petroleum. It is composed primarily of bitumen, like the other bituminous materials, a complex mixture of hydrocarbons. Asphalt is commonly used as a binder in road construction, where it is mixed with aggregates to create asphalt, concrete, or flexible pavements. It is also employed in waterproofing, roofing, and other industrial applications due to its adhesive and water-resistant properties. So, let's talk about the sources of asphalt. So, first is the natural deposits of asphalt. Asphalt occurs naturally in two main forms, the native asphalt and rock asphalt. The largest known deposit of native asphalt was located in Iraq and date back thousands of years. Additional native asphalt deposits have been discovered in locations such as Trinidad, Bermuda, and the La Brea tar pits in Los Angeles, California. Historically, native asphalt softened with petroleum fluxes was widely used as binder in highway construction. However, its properties can vary significantly depending on the deposit, particularly on the content of insoluble materials. For instance, the Trinidad deposit contains approximately 40% insoluble organic and inorganic materials, whereas Bermuda asphalt contains only about 6%. The second source is the rock asphalt. The rock asphalt is a naturally occurring mixture of sandstone or limestone, saturated with asphalt. Deposits of rock asphalt have been found in states like California, Texas, Oklahoma, and Alabama. The asphalt content in these deposits ranges from 4.5% to 18%, depending on the specific state. After mining or quarrying, rock asphalt can be processed with the addition of mineral aggregates, asphalt binders, and oil to make it suitable for road surfacing. However, its use is limited due to the high cost of transportation. The third example is petroleum asphalt, or another source for asphalt. Petroleum asphalt is derived from petroleum refining in various forms, including asphalt cement, slow curing liquid asphalt, medium curing liquid asphalt, rapid curing liquid asphalt, and asphalt emulsions. The amount of asphalt obtained from crude oil depends on the crude's American Petroleum Institute or the API gravity. Generally, crude oil with lower API gravity yield higher quantities of asphalt. Before delving into the properties and applications of different petroleum asphalts, it is important to understand the refining process used to produce them. After discussing the sources of asphalt, let's proceed to the refining process. The production of petroleum asphalts involves two primary refining processes, which is the fractional distillation and the destructive distillation. This process separates and processes petroleum into various products with significant differences in the chemical transformations involved. So first, let's discuss the fractional distillation. This method separates the components of crude petroleum based on their boiling points, without altering their chemical composition. By gradually increasing the temperature, volatile materials are removed in stages, leaving petroleum asphalt as a residue. The process may involve the use of steam or a vacuum to enhance efficiency. The steam distillation is a continuous process in which crude oil is either pumped through tube stills or processed in batches. The temperature is gradually raised to evaporate different components at a specific boiling point, and tube stills, preferred in modern refineries, are more efficient than batch processing. Meanwhile, the bubble tower separation is the once heated, the crude oil is fed into a bubble tower, a vertical cylinder with stacked trays or platform for material separation. The lighter fractions, like the gasoline or the kerosene, rise to the top trays, while heavier fractions, like the lubricating oils, settle on lower trays. The heaviest residue containing asphalt remains at the bottom. And the residue's consistency can be controlled by extending the distillation process. Longer distillation's time results in harder residue. And the products and further refinement. The initial separation yields gasoline, kerosene, diesel, fuel, lubricating oils, and a heavy residue material containing asphalt. The residue undergoes further processing to produce asphalt, cement of varying penetration grades, as well as slow and rapid curing asphalts. Emulsified asphalts can also be created through additional processing. Another method is the destructive distillation or the cracking. This method is used when a higher yield of light fractions, such as motor fuels, is required. It involves exposure or the exposing the crude material to extreme heat, up to 1,100 degrees Fahrenheit, and high pressure above 735 psi, causing chemicals to change in the material. The cracking process is the breakdown of larger hydrocarbon molecules into smaller ones. It also produces more light fractions compared to fractional distillation. Meanwhile, the limitations for asphalt production. Asphalt obtained through cracking is less commonly used in paving because it is more vulnerable to weather-related changes than asphalt produced via fractional distillation. The description and uses of bituminous binders. So, bituminous binders are essential materials in construction, particularly for pavements. They can be broadly categorized in three main types, which is the asphalt cement, asphalt cutbacks, and emulsified asphalt. Additionally, other bituminous materials such as blown asphalt and road tars exist but are now rarely used in modern highway construction. And the asphalt cements. Asphalt cements are derived after the separation of lubricating oils from crude petroleum. These materials are semi-solid hydrocarbons with specific physical and chemical properties that make them effective as cementing agents. Due to their high viscosity, both the asphalt cement and the aggregate must be heated before mixing for pavement construction. The asphalt cement grading by penetration and viscosity is historically asphalt cement grades were determined by penetration, which measure the depth in 0.1 millimeter that a standard needle can penetrate the material under specified conditions of load, time, and temperature. Soft asphalt cements have penetration values between 200 to 300, while harder grades fall between 60 to 70. More recently, viscosity grading has become the preferred method for classifying asphalt cements, as it provides clearer measure of the material's consistency at different temperatures. For the applications of asphalt cements, they are primarily used to produce hot mix, hot laid asphalt concrete, and the type of concrete is widely utilized for constructing highways, airport pavement surface and bases, parking lots, and industrial floors. The specific grade of asphalt cement determines its suitability for various applications, ensuring optimal performance in each use case. Then, the asphalt cement testing for grading. The standard penetration and viscosity tests are used to classify asphalt cements into different grades, ensuring that they meet the required specifications for the intended applications. These testing procedures will be covered in later sections. Asphalt cutbacks. Examples of these are slow curing asphalt, rapid curing cutback asphalt, medium curing cutback asphalt, the emulsified asphalts, and the blown asphalt. So first, let's talk about the slow curing asphalt. Slow curing asphalts are produced by distilling crude petroleum or by adding heavy distillates like diesel oil to asphalt cement. They have lower viscosities than asphalt cement and harden slowly. Slow curing asphalts are classified by their kinematic viscosity of 60 degrees Celsius, with designations such as SC70, SC250, SC800, and SC3000. These asphalts are no longer specified in the ASH2 standard. The medium curing asphalts is the second asphalt cutback. It is made by mixing asphalt with light fuel, oil, or kerosene. These asphalts harden faster than slow curing ones, with grades like MC30 being more fluid. The amount of solvent determines the fluidity, with MC3000 containing 20% solvent and MC70 up to 45%. They are used for pavement bases, surfaces, and surface treatments. The third one is the rapid curing asphalts. These are created by blending asphalts with a highly volatile distillate like gasoline or naphtha, which evaporates quickly, speeding up the hardening process. The grade of rapid curing asphalt is determined by the solvent content, with examples like RC3000 containing 15% solvent and RC70 containing 40%. These asphalts are used for similar applications as the MC series, and their specifications are provided in a ASH2 standard specifications for transportation materials. The fourth one is the emulsified asphalts. These are made by breaking asphalt into tiny particles and suspending them in any water with an emulsifier. This type of emulsions include anionic, cationic, and non-ionic, classified based on the electrical charge surrounding the particles. Anionic and cationic emulsions are commonly used in highway construction and maintenance, while non-ionic emulsions may see more use in the future. They are classified by how quickly they return to their original consistency: rapid setting, medium setting, and slow setting. Cationic emulsions are more effective with siliceous aggregates, while anionic emulsions work better with aggregates like limestone. Emulsions must be protected from freezing, as they can break down in cold temperatures. Blown asphalts is the final asphalt cutback that we will be discussing. These are created by passing air through semi-solid asphalt residue at high temperatures, making the material stiffer. This process gives the asphalt a firm consistency that can withstand high environmental temperatures. And that will be my discussion about highway soil and bituminous materials. Thank you.